Guess who's back? Back again. Guilty's back. Tell a friend. I'm back. Get over it. Let's go. Today we're talking about implicit differentiation. Let's put the topic. It's a very different idea. Like you use standard derivatives. It may seem pretty like alien at first, because when you do a derivative, for example, you say f of x equals x squared. When you differentiate, you say f prime of x equals 2x. Right? This is what you usually do, but implicit, it's really weird because you're used to having y on one side, but now y is mixed in with x, and you have like xy equals tangent of y, and you're like, how the hell do I solve this? But the truth is, you've been doing this all along, and the idea is that the chain rule. The truth is that every variable is dependent on every other variable in some context. It's really rare, at least in single variable calculus, so calc 1 and 2. It's really rare that you have like two independent variables that do not depend on each other. Most of the time, you're talking about, even most of the time in calc 3 too, most of the time the variables depend on each other. And that's like the entire idea of calc. And we're trying to like measure how they change, because they're most of the time they're dependent on each other. So whenever you take a derivative of a variable that is not the basis of the derivative, you have to call it, my old math teacher called it, you have to do a chaperone, which is what he used to call it, which is essentially just a chain rule. Because the idea is that if I have y is a function of x, right? Then I take a derivative of this. This is technically taking the derivative of the variable itself, y, which is 1, times the derivative of y, dy dx. Because this is technically the chain rule. That's what the chain rule is at its very core. You're taking the derivative of something that's the outside, and you're multiplying the derivative of the inside, which is the derivative of y. That's the entire idea behind the implicit differentiation. So, to apply this, when you're trying to find, they're trying to ask you to find dy dx, given like an equation of this, they're trying to find how does y change with respect to x, given that the x and y is related in this format, or any other format. So let me write down some examples. In fact, cosine of xy equals e to the y. Right? This is a constraint. What we call. What I'm asking you is, what is the rate of change of y with respect to x? In other words, if I increase x by one value, how much values does y change by for any given x and y? That's what the question is. So we can do that by using the same idea that I just erased, by using chain rule. So let's do that. Let me walk you through it. So for example, this is product rule right now, and you may like you're still starting it. So let's skip product rule for now. Let's first talk about this. Well, you've obviously known. Let's do the chain rule this time. Derivative of tangent is what? Secant squared. Secant squared y. Right? You keep the y in the inside. Don't do anything. Now this is the chain rule part. What is the derivative of y? It is dy dx, or y prime, because y depends on x in some way. So the idea is that if y depends on x in some way, the derivative of y with respect to x is just the derivative of y with respect to x. That's what we're trying to find. We're not trying to find this. We're trying to find y prime. That's what this chain rule means. You differentiate the outside and you multiply with the derivative of the inside, keeping the inside unchanged. That's what this is. So now, keeping that logic, we get rid of this. Let's differentiate this. This is a product rule, right? Lefty right plus righty left. That's how I remember it. So lefty, which is derivative of the first of the left part, dy dx. Same thing. Times 1, right? Plus this y times the derivative of x, which is also 1. Now keep in mind, all we're trying to do now is find y prime in terms of y's and x's, given that we actually have no y's and x's in this thing, but you know. So what we can do is we can subtract this y over, subtract this one over, and we get we'll get another expression. So we get y prime minus secant squared y times y prime equals negative y. Then what we can do is, you've been to algebra, factor out a y prime and then divide that over. So you get a y prime equals 1 minus secant squared y equals negative y. Y prime equals negative y over 1 minus secant squared y. That's it. What we're trying to find is how y relates to x. And we're doing that by using chain rule. We don't care about y's and x's. So yeah. So let's do this for the next one. This is giving me a little more. Oh, this is cox. I did cox. I just realized that. My bad. Cosine of xy equals e to the y. Let's do this. What is the derivative of cosine? Negative sine of xy. Keep in mind, don't change the inside. Then we're gonna multiply by the derivative of xy, which we just got. It's y prime plus y. You know, it should not be y prime. I think I made a mistake. Yeah, no, this is supposed to be x. Oops. Right? That equals e to the y times y prime. Same thing, right? We're always bringing down that chaperone. Now, all we're trying to do is try to isolate y prime. That's all we're going to try to do. This is going to look messy, but trust me, it is doable. Let's multiply this out. So we get negative, right? We're trying to isolate y prime. So let's add that, subtract this on this side, add that on that side. We get negative y. Factor a negative, or like just factor out a y prime. We get a y prime times negative sine x sine y sine of xy, and then we just divide that over and we have a y prime. Y. And that's it. What you're doing is just bringing down a chaperone and then finding what that chaperone is. That's all this is. So, yeah.